Okay, so I have the question that says, solve the system of equations using a graphical method. Right. I will have equation 1, and I'm going to label it equation 1 and equation 2. It's important to note that these equations are linear equations. And to graph any straight line or any linear equation, you simply just need 2 points. So I'm going to take this equation and I'm going to try to find 2 points. Good. That means I need to find the x value and the y value for the equation. So I'm going to say, okay, when x is equal to 0, what the value of y should be. And I like using 0 because it makes my life easy. So I'm going to have 3x plus 2y is equal to 7. And I'm just going to substitute 0 inside of this equation. 0 for x plus 2y is equal to 7. So 3 times 0 is 0. So I'm going to have 2y is equal to 7. And to get y on its own, I need to divide both sides by 2. So y is going to be equal to 3.5, which is 7 divided by 2. Great. So the first coordinate I'm going to have is x to y. That's going to give me 0 and 3.5. Great. So that's 1 point. We need another point, right? So I'm going to say, okay, when x is equal to, let's try 1, when x is equal to 1. So I'm going to say, okay, 3x plus 2y is equal to 7. And we're going to change out that x for 1. Put back everything behind it and what was in front of it. So 3 times 1 is 3. 3 plus 2y is equal to 7. When I carry this 3 across, it's going to become minus 3. So 2y is going to be equal to 7 minus 3. And that works out to be 4. Then I'm going to divide both sides by 2 to get y on its own. So y is going to be equal to 4 divided by 2, which is 2. So the second point we would have had is x being 1 and y being 2. Great. So that is what we're going to use for the first graph, right? So far, very easy. So let me just put this in one color. So I'm going to be using these 2 points to make the graph of the first line or the first equation. So I'm going to go squiggly diggly do, and then I'm going to do the second equation, this one. Whoa, great. So I need to find out the value. I'm going to pick any random x value. I'm going to say, okay, what if x was, you guys know I like using 0. What if x was 0? I'm going to have to say, okay, 5x minus 2y is equal to 1, where x is now 0. I'm going to put back everything before it and solve. 5 times 0, that's 0. So I'm going to have minus 2y is equal to 1. And to get y on its own, I have to divide both sides by not 2, but negative 2. Good. This will cancel, leaving me y is equal to negative a half. So the coordinates for this point would be x. Notice I'm always putting x first. X was 0 and y was negative a half. Great. So we still need to find one, that's just 1 point. So any straight line, to draw it, you need 2 points. So I need to pick another x value. I'm going to see, what if x was 1? Right. And then I'm going to substitute x for 1 in the same equation here. So x for 1, everything before x, everything after x. 5 times 1 is 5. 5 minus 2y is equal to 1. And when I carry this across, it's going to become negative 5. See that? Negative 5. So minus 2y is equal to 1 take away 5, which is going to be negative 4. And then now I'm going to divide both sides now by negative 2. So y is going to be negative divided by negative, going to give us a positive. 4 divided by 2 is going to be 2. Awesome. So my coordinates, x and y, x was 1 and y was 2. Great. So I'm going to put this into a different color. And these 2 points are what we're going to be using to create the graph of this line. Alright, so I have my graph up here. Oh, my graph up here. Oh my god. Here I have my graph paper. And it's already pre-prepared. Right, this is my x-axis running from left to right. And this is my y-axis running from north to south. Great. So remember all those coordinates that we worked out? So I'm going to start with the pink ones first. So I need to find 0 on my x-axis and 3.5 on my y-axis. Alright, so 0 on my x-axis is right here, and 3.5 on my y-axis is going to be, this is 3, this is 4. So 3.5 is halfway between 3 and 4. So there's 1, 2, 3, 4, 5 spaces. So I need 2.5. 1, 2, and there's a 0.5. So at this point, it's going to be 0 and 3.5. Great. It's right here, right? So that is the first point. So we took care of this. So I'm going to need 1 and 2. 1 on the x, 2 on the y. So x is this, 1 on the x and 2 on the y right here. Good. Now that I have those 2 points, what I can do is to just draw a straight line connecting them. Right. Voila! Great. So I connected these 2 points and notice that I end up with a straight line. And just for ornamental purposes, I labeled it 3x plus 2y is equal to 7. Awesome. Now we're finished with the second point, which means that we're finished with the first equation, this one. Now we're going to look at the second equation, which is these two. So I'm going to need to plot this point, x being equal to 0 and y being equal to negative a half. So x equal to 0, this is the x, 0 is right here, and y being equal to negative a half. Negative is going downwards, and a half is between 0 and 1, right? And there's 1, 2, 3, 4, 5. So a half of 5 is 2.5. 1, 2, and right here. So this is where negative a half would be, right? So I'm going to put my coordinates 0 and negative a half, or negative 0.5. So that would take care of the first point, this one. So I need to look at this one now. When x is 1, y is 2. Alright? So x is 1 and y going up should be 2. Hey, look at that. They meet at the same point. Interesting. So should be x is 1, y is 2. So what I'm going to do now is to draw my straight line to connect those two dots. And there you go. We have that new line. So this is the new line. And for make it pretty and nice, I put 5x minus 2y is equal to 1. Now, look what, do you see something? Like, you know, something happening between the two lines. And that's the whole point of simultaneous equations. It's where two conditions meet, where two things share a common point. And that common point is right here, right? That's a common point. And if you drag this down, it's telling us that, look, that value is 1, or x value is 1. And then if we go across, it's saying, look, or x value or y value here is 2. Good. So this is a point where they meet when x is 1 and y is 2. And this is how you show that you're solving the simultaneous equation graphically. And this becomes very important when we're doing stuff like markets, where demand meets supply. You want to find out where they're equal. At what price would I want to pay for something that somebody would want to sell it for, right? And other things like costing and pricing, and pretty much, yeah. So this is where you find it very useful, and it can help you to set prices if you are a person who sells stuff, and it can help you to determine if a price is right for me to buy something at. Okay, so if a patty was like $80 and I was like, too high, too high, it can help you to make decisions, financial decisions like that. And when I was a auditor, and when I used to work at a bank, these are some of the things that we looked at, right? So it's pretty fun and interesting. I can do a whole heap of things with it.